Hello, we're gonna talk about still. It is the Bike Initiative. I gotta show this page again. And then we're gonna be working on optimization today still for AP Calc BC. This is like a lot of calculations in this work. Often multiple choice, a little bit times FRQ, but and then like when we're learning this unit, a lot of people get confused. So I think it is important that I go over this concept again. Yep. So what is optimization? Optimization is either like finding the max or min of a function in a real world context. Something could be like profit, area, volume, or which we want to maximize, or sometimes we want to minimize the cost, the time consuming, and the distance away from those. We use derivatives to find the critical values that we have already learned about the first and second derivative stuff. Then we are gonna continue over there. And so here are some like just genuine steps that people often use for solving those optimization problems. Like we want to define those variables. So we want to write out functions of what you want to max or min, such as if you want to say like area. So if you want to maximize area, then you got to know the y's and width and the length of a rectangle, for example. Then you set a equals to a constant times a constant, or maybe a function times function, and then we continue from there. And then yeah, two, which I covered, we want to express that function in terms of one variables, which we see the relationships. And then our goal is you only want to contain one x or one y, because that's how we're going to keep going. Then we want to find the domain, such as like most obvious is sometimes the problem will tell you it goes from like maybe the first day to the 15 days, and then sometimes you're going to use some common sense, such as like time is never negative, area is never negative, distance is never negative. And then we will take the derivative, such as maybe you found out that area equals to x times 18 minus x. Then you take the derivative on that side. Then we find those critical values and then do the critical value test, or sometimes we call it a candidate test, to actually see the optimization values. Okay, I know this might sounds like a huge ton of information, but we'll go like simple problems first. I promise it won't be that difficult. Like the first simple example, same as before, written by ChatGPT. It states that a rectangle is to be inscribed under one arc of the curve y equals to sine x from x equal to 0 to x equals to pi. What is the maximum area? Like the first thing we'll notice is, since it's symmetrical around pi over 2, so the area we can write out the function 2x times sine x, and then we want to maximize 2x times sine x. We'll take the derivative of the right side, which I don't want to write it out here, and then but we can still do it. It's 2 sine x plus 2x cosine x. And then from there, we want to find if for those derivative, 2 sine x plus 2x cosine x, we want it to be 0 in order for it to be a critical point, as we learned before. And then we plug in that corresponding value back into there. We found the max value, and then we'll just interpret it from there. Yep. And then here's another example, like such as we want to make a cylinder can with volume of 1,000 cubic centimeter using the least material possible. What is the dimension? What is the dimensions which will help us minimize the surface area? So like telling you the surface area, V is pi r squared times h, and then we'll separate one variable, as we say, which is h is 1,000 over pi r squared. The only variable here is r squared. And then that's just the volume, which we know h. And then the surface area is 2 pi r plus 2 pi r h for a cylinder. Like it's the two circles on the top and bottom, and then we use the middle as also like a rectangle. If you guys are interested, you guys can search it up. As some probably is given if you guys are doing the problem, or this is, I don't think it is that hard. And then what we do now is we substitute 1,000 over pi r squared into that h, and then then we find the derivative of the right side, and then we do the candidate test and then plug the value back in, which we will know what is the maximum area, and then we'll solve for R and H in that case. Okay, now we're gonna hop into some real style AP questions. So the first one says, a company has started selling a new type of smartphone at the price of $110 minus 0.05x, where x is the number of smartphones manufactured per day. The parts for each smartphone cost like $50, and the labor and overhead for running the plant costs $6,000 per day. How many smartphones should the company manufacture and sell per day to maximize the profit? And then it tells you the profit is revenue minus cost. Okay. So P is profit per day, and then X is the number of items manufactured per day. This is what we define first about the variables. Then we want to see the relationship between them, which profit is X times 110 minus 0.05X, which is price times quantity, which will give us revenue. And then we want to minus 50X because each smartphone costs $50 and then $67 per day. And then where X is only bigger than 0, this is the only constraint for the domain. And then if you take the derivative on the right side, which is X times blah, 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 and then we do the candidate test and then plug it back in, you found out the best number to sell for smartphone is 600. Yep. And then there's another one. Which we have here. It says a rancher wants to construct two identical rectangle corrals using 200 feet of fencing. The rancher decides to build them adjacent to each other, so they share fencing on one of the sides. What dimension could the rancher use to construct each corral so that together they will enclose the largest area? Okay, so the total area of two corals is A, which we defined, and the X is the length of the non-adjacent sides of each coral, which will give us A is 2x times 200 minus 4x over 3, which is like the y times the length for a rectangle, and then which we again expressed A in terms of x, so we putting them together with a relationship. And then we'll have 0 smaller than x less than 50, because if it's not smaller than 50, 200 minus 4x will be a negative number, which will not work. And then it's the same thing. You take the derivative on this side and then do the candidate test and plug it back in for the largest area which we want. And at the last we found 25 feet for non-adjacent sides and then 100 over 3 feet for those adjacent sides. Like for those types of questions, the hard part isn't those calculations. It is tough in calculations. But still, like, as long as you have those equations, such as A is blah, 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 then just taking the derivative and plugging it back in. It only takes time. And then if you study like good about previous unit, will be perfectly fine. So the only hard part is you need to link them together in those real contests. You need to link the two variables or even more together. And then from now there you can continue. And then, yeah, that's it for today. If you have any corrections, visit our Viking Initiative website and then join our AP Calculus BC study group for more information. Just thank you so much. There will be tutors in those WhatsApp groups. Enter your question if you ask. And then that's it.